We're on page 28, and we're going to be doing problems 1D and 1G, and then problems from problem number 2, B, F, J, N, and last of all, P. So the problem 1D on page 28, we're given the ordered pair 2 minus 3 and the ordered pair 3 comma 1, and we're asked to find the slope. So the slope M is equal to the difference in the y's over the difference in the x. So we call this x1, y1, and this x2, y2, then 1 minus 3 is the difference in our y's over 3 minus 2 is the difference in our x's. So 1 minus 3 gives us 4. 3 minus 2 gives us 1. 4 over 1 gives us 4. It doesn't matter which ones we call x1, y1, x2, y2. We could reverse them. So it doesn't make any difference. The slope would still be the same. So in 1G, we're given the ordered pair minus 3 comma 6 and minus 5 comma 6. And you can see by looking at these that the x value changes from minus 3 to minus 5, but the y value doesn't change. So really, y is 6 no matter what the value of x is. So if we draw y equal to 6 here, there's the line y equal to 6, and you can see it's parallel to the x-axis. So this is the x-axis, so y equals 6. So if we were to actually calculate the slope for this line, it would be the difference in the y's over the difference in the x's, and the difference in the y's would be 0 because 6 minus 6 is 0, and the difference in the x's would be minus 5 minus 3, which would be minus 5 plus 3. So it would be 0 over minus 2, which would be 0. So this line has a slope of 0, and any line that's parallel to the x-axis has a slope of 0. And any line parallel to the x-axis would have the equation of y equals a number. For example, if this were right here, we might say y equals 1, y equals 2, etc. Here we're up at y equals 6. If the line were parallel to the x-axis and below, then it would be y equals a negative number. Another way to look at this is to realize that we could write the equation as y equals 6 plus 0 times x, because 0 times x is 0. So no matter what value of x we put in here, y always equals 6. See, so if I come up from this x value to the y is 6. If I change the y down here, if I change the x value, and go up to where it crosses, the y is still 6. So here, let's say x could be, let's say, minus 3. Y would still be 6. Here, let's say x might be equal to 5. When x was 5, y would be 6. So no matter what the value of x is, I can put any number what I want, y is always 6. Now, number 2b, page 28. Here we are given the slope minus a quarter, and we know the y-intercept. Now, if we draw this point 0, 5 here. This point right here represents the y-intercept because it crosses the y-axis. This is the y-axis here. So the point at which a graph crosses the y-axis is called the y-intercept, and that is the value of b in the equation y equals mx plus b. So since we know the slope and we know the value of b is 5, we can just substitute it into this. This is the slope, and this is the value of b. Now, supposing we were asked to draw the equation of the line, this is just an additional point on this. One way we could draw the line is start off at the y-intercept 0, 5, which is this point right here. Okay. So we start off at this point 0, 5, and move down by 1. Why? Because the slope is minus a quarter, which means we could change y by minus 1, and we have to change x by plus 4. So since we have to change y by minus 1, we move down by 1. And since we change x by plus 4, we move to the right by 4. So we move down 1, we come to this point, and we move over to 4, and we come to that point. So moving down from the initial point 0, 5, and moving down y by minus 1 would take us to 0, 4. And increasing x would mean that the 0, 4 over here would be 4, 4 because we've changed the x by 4. And we draw a little x here to indicate this. And then we connect the intercept to that. Now this is a little off here. I see right here this line should be drawn a little lower through this point. And so that just gives us an indication of how we could draw the graph. So let me repeat this. We start off at the intercept 0, 5. From the value of the slope, we know how to change the y value and how to change the x value. And we change the y value by 1. We move down 1 here. And then we move across by 4 because of this 4 here. And we come to 4, 4. We mark this point with an x. We connect this point to the intercept at this. And that draws the equation of the line. I'm sorry that this line here, this one doesn't fall right on the x. It should. We move down by 1, and we move to the right by 4. That takes us to this point here. Find the equation of the line with a slope of minus 4/3 and through the point 2, 2. Well, here we can use the point slope formula because this is a very simple formula, and we use this when we have a point y1, or excuse me, x1, y1, which is this here, x1, y1, and we have the slope. So all we have to do is substitute into here, and what we do is y1 is 2, x1 is 2, and the slope is minus 4/3. So there's the answer right there using the point slope formula. Now, we can change this if we wanted to. We could change it into the form y equals mx plus b. Now, what I do here is I move the minus 2 from the left-hand side to the right side, and I remove the brackets. So if I remove the brackets, first of all, I get minus 4/3 x by the distributive rule right here. Minus 4/3 times minus 2 gives me 8/3. So I'm multiplying this times this to give me that. And I'm multiplying minus 4/3 times minus 2 to give me plus 8/3. And I move the minus 2 from the left to the right and change the sign. Now what I do is I just say, okay, I'm going to leave this the same. I'm going to leave this the same. Instead of 2, I'm going to write 6 over 3 so that everything is over 3. So all I've done in going from here to here is to change 2 into 6 over 3. Now I can combine the 8 plus the 6 and get 14 over 3. So I now have the equation y equals mx plus b in the form this. This answer and this answer are the same. Let me repeat. This was obtained from the point-slope formula. This is now in the form y equals mx plus b. These two are exactly the same. Although you can't see it, they are the same or equivalent. Now, we could also do this by using mxb directly. In other words, let's start with y equals mx plus b. We know that m is minus 4/3. How do we know that? We were given that. So now what we do is we substitute the pair into there, 2, 2. For the x, I substitute 2. And for the y, I substitute 2 because we know it's 2, which means x is 2. When y is 2, I put the 2 here, I put the 2 here, and solve for b. And when I solve for b, minus 4/3 times 2 is minus 8/3. And instead of 2, I'm going to write 6 over 3. I'm going to transpose minus 8/3 from the right side to the left and add it to the 6/3, and I get 14 over 3. So get y equals minus 4/3 x plus 14 over 3. So what I've done is I've used mx plus b instead of the point-slope formula, but I've used the points indirectly, and I come out with exactly the same answer. This shows that when you're doing this kind of problem, there is usually more than one way to do it. You can use the point-slope formula, or you can use the slope-intercept formula. This is the slope-intercept formula, and actually calculate what the intercept value is. Now, 2J, in this particular case, we are asked to find the equation of the line through 2, 4 and minus 4, 6. So again, the very first thing, we're given 2 points. When we're given an ordered pair, the first thing we do is calculate the slope. So here, the difference in the y is 6 minus 4. So we got that. Difference in x is minus 4 minus 2. This gives us 2 over minus 6. And if we reduce that, we get minus 1/3. So we know what the slope is. It's 1/3. We could substitute into the y equals mx plus b, which is the slope-intercept form, and then calculate as b as follows. We know the slope is minus 1/3. Now what we could do is calculate b. So we can use the ordered pair 2, 4. We can use minus 4, 6. It doesn't matter which one we use. We'll get the same answer. So here we put x equal to 2, y equal to 4 into this equation. So for 4, y we have 4, and for x we have 2. And then what we do is we say that b equals 4 plus the 2/3, because this times this will give us minus 2/3. If I transpose it to this side, I get plus 2/3. Now if I choose a common denominator, 4 is 12 over 3. So instead of writing 4, I'm writing 12 over 3, because 12 divided by 3 gives me 4. And then I add these 2/3. 12 plus 2 is 14 over 3. So 12 plus 2 is 14. We have the 3, so we get 3. So therefore, putting this back into this equation, we now have the intercept and we have the b value, and we write y equals minus 1/3 x plus 14 over 3, which is the same as writing minus x over 3. 1 times x is x, or minus 1 times x is minus x, and the 3 is here. So this one and this one are equivalent statements. Now, you can see that if another method that we could use is to take one of the points and put it into the point slope form. When we do that, right over here, so we've got y1 is 6 and x1 is minus 4 right over here. So we take the x1, that's minus 4, and when we do that, we transpose the minus 6 from the left to the right, I get plus 6. So we're just taking this formula, substituting minus 6 for the y, substituting minus 4 for the x1, and we get this equation here. And we've transposed the minus 6 from the left to the right. Now, using the distributive rule, minus 1/3 times x, I get that. Minus 1/3 times the plus 4 gives me minus 4/3 plus 6. Now I'm going to change the 6 into 18 over 3. Combine the minus 4 and the 18, and I get plus 14. So I get minus 1/3 x plus 14 over 3, or minus x over 3 plus 14 over 3. Now notice I used minus 4, 2, 6 here. I could have used the other ordered pair I was given, 2, 4. So you can see here again, whether we use the slope intercept form or whether we use the point slope form, we still come out with the same answer. Here again, we're given 2 points. We're given minus 3, 7 and minus 3, 5. Now, right away, I can see that no matter what the value of the y, x stays the same. Well, if x stays the same, the equation of the line must be whatever that number is right here. In this case, x equals minus 3. So here's the equation of the line, x equals minus 3. Here's the origin. And one way we can look at this solution is to write it as x equals minus 3 plus 0 times y, because 0 times y is 0. So no matter what value of y we use, x is minus 3. What does that mean? Supposing the y value is right here, say it's 5. So x is minus 3. We go down here. Let's say this is minus 4. X is still minus 3. You'll notice that when we actually calculate the slope of this line, we take the difference in the y's, 5 minus 7. So the difference in the y is 5 minus 7 over the difference in the x's, which is minus 3 minus minus 3. That leaves us with 0 on the denominator. Whenever you have 0 on the denominator of a fraction, that means that this is undefined. How do you define how many times 0 goes into minus 2? You can't do it, so we say it's undefined. Lines parallel to the y-axis have a slope that is undefined, so it doesn't matter whether the line is here, or the line is going down from here, or the line is going down from this point. These are always the vertical lines always have a slope that is undefined, okay? And they are parallel to the y-axis. There's the y-axis. This line, x equals minus 3, is parallel to the y-axis. And these equations have, these lines have the equation x equals a number. In other words, if a line has a slope that's undefined, it's parallel to the y-axis, and the equation of the line is x equals a number. In this case, x equals minus 3. Supposing the line was over here. Well, then if that's the case, it might be x equal to plus 3. So this is very similar to the previous problem, and you should know the difference between lines that are parallel to the x-axis, which have a slope of 0, and lines which are parallel to the y-axis, which have a slope that is undefined. Okay, so here we're given a problem where the ordered pairs are actually intercepts. So what we're going to do, first of all, we're given two ordered pairs, as we've done before. We look at the change in y of the change in x, y2 minus y1, so 4 minus 0 over 0 minus minus 3, and that gives us 4/3. Well, the fact is that this point is actually the y-intercept, and we know the y-intercept is the b value where it crosses the y-axis. This value here is the b. So we now have the slope and we have b. So the equation is y equals 4/3 x plus 4. Now, supposing you didn't realize that this was the value of b, and you chose another method of doing it. You chose the point slope form. Well, we know what the what the slope is, so we know m, and we know a value, and we put that into the point slope form. So m is 4/3, as we've calculated. X1 is minus 3, so that's right over here. X1, instead of x1, we put minus 3, so we've got minus 3. And y is 0. y1 is 0, so I'm going to substitute for 0 right here. So I'm substituting for the y1 0 here, and I'm substituting x1, the minus 3, over here. When I do that into this equation, I get this. And this gives me y equals 4/3 x minus 3 gives me plus 3. Now when I use the distributive rule on this, 4/3 times x gives me 4/3 x. And 4/3 times 3, the 3 here cancels with that 3 right here, and I get plus 4. Notice that this is the same as what we previously obtained when we used the slope and the y-intercept form. Another thing we can do is check the answer, check this answer, or the other one, by verifying the equation using the second ordered point. I used minus 3 comma 0 to derive this equation. I could use the other point to verify that I have the right equation. So when x is 0, y equals 4 if this is the right equation. So substituting x equal to 0 into this equation, we get 4/3 times 0 plus the 4 because of this here, so that 4 becomes that 4. 4/3 of 0 is 0. 0 plus 4 is 4. So when x is 0, y is 4. This tells us that the equation is correct because if we didn't have the right equation, when we chose x equal to 0, we would not get y equals 2, 4.